Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. Please tell me, am I properly audible and visible to all of you or not? Yes, fine. So, guys, we are starting the session. This is a special session for GATE and ESE 2024. And here we are going to see the questions on strength of materials. And we are going to see top 10 questions. Nirved, good morning, dear. How are you? So guys, we will see some wonderful question here. This is some detail about me and this session is about strength of material. So guys, we are going to see some wonderful question today. Pajal word, good morning. So whatever the question we are going to discuss, they are equally important for all the examination like BARC, ISRO, DRD also. But majorly this is under the series of GATE and ESE. So we are starting it. So guys, one more session is there today only at 4 p.m. on the BYJU'S exam prep app. So you can also join this session today only for more 10 questions. They will be different than this set questions. Akash, good morning, dear. So guys, one more information before we start the session. 25th of June, 9 a.m. you have the scholarship test. By attempting this scholarship test, you can get up to 90% of the scholarship on the GATE preparation program. And guys, after that, this last information is about workshop. 27 June, 7:30 p.m. There is a workshop on strategy to be in top 1% in GATE 24 would be taken by Richa Gupta ma'am. Okay. हाँ बिल्कुल Pajal word we will be coming up with that. I will send also, but I am planning to take session on that. That's why I have not shared till now. I am planning ki we will take the session on that. Okay. So this is the very first question, guys, in front of you. So do like and share the session. A sample of a material is tested in tension and it is found that there is a strain of 0.0080 at a corresponding stress of this. So we can say that there is a stress strain diagram and let us say this is the stress strain diagram going on like this. The stress is 450 and corresponding to this strain is 0.0080. And then they are saying that on the removal of the load, you know, when you will be going for unloading, it will be coming parallel like this and this slope are same. And my dear, they are saying when we are coming back, we are reaching to this point, 0.0015. And they are finding us the modulus of elasticity. I feel everybody is aware that if this angle is theta, this angle is theta, then everybody is aware that the slope is given as tangent theta. And slope is nothing but the Young's modulus of elasticity. So my dear, this is very easy now. It is just like a geometry question. This is a triangle from which you need to find out the tangent theta. So tangent theta is going to be Young's modulus. Can you find out? Obviously, this is y, this is x. It is going to be dy by dx. It is going to be 450 divided by 0.008 minus 0.0015. Solve it and get the answer. This is the type of question nowadays are repeatedly coming in the GATE examination. Previously, this type of questions were not coming, but nowadays they are asking this type of question. So, Pajal, Nirved, Akash, and company and Oli, yes, good morning. So, just solve this question and try to give the answer. I am waiting for your answer, and then we will move to the next question. So, in this way, we are going to cover 10 questions in this session, and you can get 10 more wonderful questions at 4 p.m. on the BYJU'S exam prep app. So, you will get this PDF on my Telegram channel, and these questions are such that you must add them in the notes because they are the good types of question, new types of question. Jaya Krishna is saying the answer is A. Very good, Jaya. And whatever Jaya is saying, answer is correct only. Okay. But I feel the power is missing here. The power will be 10 to the power 5. Okay. Yes. So the answer will be very good, Nirved. Answer will be 6.92 into 10 to the power 5 Newton per mm square. Yes, very good, guys. Wonderful. Moving to the next question, guys. Moving to the next question. This question is from the principal stresses, or you can say complex stress and strain. Two planes, AB and BC, which are at right angles, carry shear stresses of intensity 26 while the plane AB carries a tensile stress of 60. From the given loading condition, we can say that 60 is sigma xx, 26 is tau xy. There is no discussion about sigma yy, so you can say sigma yy will be 0. And they are asking you that find out the normal and shear stress on the plane AC inclined at 25 degree. This is inclined at 25 degree anti-clockwise. So for this case, we have already derived the expression. You know, we can say that here some normal stress will be coming sigma theta. Some shear stress will be coming tau theta. So sigma theta formula was sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. This will give you the value of sigma theta. Then you can go for the tau theta as well. Let us see how many of you give the right answer for this. This will give you the sigma theta, and you know tau theta formula is, tau theta is sigma xx minus sigma yy by 2 sin 2 theta minus tau xy cos 2 theta. You can apply these formulas and get the value of sigma theta and tau theta. Just solve it. Nirved, Jaya, Pejal, Company, Akash. Yes. Everybody, do solve it. Do solve it. And do like and share the session, guys. Do like and share the session. Do like and share the session. Yes, everyone. Fine. So for this question, Nirved is saying answer is option A. What about others? What about others? Yes, 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 guys. Tell me. Jaya is also saying A. Okay. You will get normal stress as 69.2 Newton per mm square. 69.2 Newton per mm square. And you will be getting the tau theta as 6.26 Newton per mm square. So the answer for this question, my dear, will be A. Moving further, guys, this is the Mohr circle. Now we have question from the Mohr circle. This is wonderful question, guys. The Mohr circle for certain stress system is shown in the figure. The principal stresses, major and minor, in ampere respectively are. So my dear, this is the Mohr circle, and you can see that this will be the value of sigma xx and this will be the value of sigma yy. Okay, you can see that because this is the point which will give you state of stress on x phase, which is nothing but 250 comma minus 150. At this point is nothing but 0 comma plus 150. So these are the state of stresses on x phase and y phase. So I feel it is very easy for you to identify that if the distance from this to this is 250, this is 150, then my dear, you need to find out the principal stresses actually. Okay, so first of all, you can find out this center point. Center, we are denoting it by sigma star. And once you get it, my dear, you know this value, you know this value, you can find out the radius. Then you know sigma 1 is nothing but sigma star plus radius. And sigma 2 is nothing but sigma star minus radius. This is what you need to do. So this is a wonderful question, guys. Just try to solve it. So everybody is aware that what will be sigma star? Sigma star can be written as sigma xx plus sigma yy by 2. You know, from here sigma xx 250, sigma yy 0. Because you can see if total is 250, sigma star is 125. So here also with solving you can write it is 125. So once you get this, this is 125, this is 150. find out the radius by Pythagoras. Okay, when you will find out the radius by Pythagoras, it will be coming out to be 125 ka square plus 150 ka square. After getting this radius, just add the radius here, subtract the radius here. You will get the value of principal stresses, guys. This is the question number 3. Please try to solve it. Nirved is saying the answer is B. What about others? Yes. Jaya, Pejal, Akash. Tell me, guys. Yes, everyone. Jaya is saying B. Nitesh is saying B. Very good. Nirved is saying B. So, guys, you will be getting, first of all, what is the radius value you are getting, guys? What is the radius value you are getting? What is the radius value you are getting here? Can you tell me? So, when you will be doing it, sigma 1 is sigma star plus radius. This will give you 320.26. And when you will be finding out sigma 2, sigma star minus radius, that will be coming out to be minus 70.26. That is very much clear that this value is going to be negative. Yes, radius will be 195.25. So B is the correct answer for this. Moving further to question number 4, guys. Once again from the Mohr circle. So here the Mohr circle is shown in the figure. The normal and shear stress on the plane CD are respectively. So they are asking you the normal and shear stress. You must be aware of that. This will be giving you the normal stress and this will be giving you the shear stress. This is very easy. Once again, I am giving you the hint. They have given you the diameter of the Mohr circle. You just find out the radius of Mohr circle. Radius will be nothing but 11,500 by 2. So this radius is R. Now if you see this triangle properly, my dear, you know that this is, let us say A. So you will be getting CA as R cos 60. You will be getting AD as R sin 60. So AD is directly the value of tau theta, which you need to calculate. And when you get CA, I would be telling you that sigma, what you need to calculate is, this is nothing but the radius minus CA, because our answer is sigma. So that will be sigma. So you can directly find out this is a good or new type of question. This is a good and new type of question. Just try to solve it, guys, and you will get the answer. Try to solve it, guys, and you will get the answer. Very good, Nirved. So here, my dear, if you will go by 1 by 2 of 11,500, this will be the radius. And I feel radius will be coming out to be 5750. After that, you can very easily find out CA, AD, and sigma. Just solve it, guys. Just solve it, guys. Yes. Okay, Ritesh have said the answer to be D. What about others? When you will be solving this, it is 5750 cos 60 degree. The answer is going to be what? They are saying that normal and shear stresses. It is 4980. and this is radius minus CA. This will be 2875 MPa. So answer will be D. Yes, Nitesh and Jaya, your answers are correct. Nirved, you got it or not? Please tell me that. Nirved, you got it or not? Please tell me that. Nirved, you got it or not? Please tell me that. Nirved, you got it or not? Please tell me that. Okay, try it. Try this. What is the difficulty? R sine 60 will be this. Sorry, this is sine 60, not cos. R sine 60 will be this. This angle is 60 degree. Theta is 60 degree. Okay, Nirved, angle is 60 degree. I feel now you can do it. Wonderful, guys. Okay. Then it's fine. You can do it by 60 degree. Moving to, guys, question number 5. This is a very good question, and this is from the SMD BMD, where they are asking the shear force at a section close to the fixed end is equals to. This is the loading diagram given. Okay. So try to solve this. This is question number 5 for us. After that, we have 5 more questions. Okay. So the session will be not too long. It is small only. Okay. Graham Bell is there. Graham Bell is saying the answer is C. What about others? What about others? You know that this is the beam. We have M here, 2M here. Nitesh is also saying C. Yes, Nirved and Jaya, what do you feel? Pejal, Akash, everyone. So my dear, if you see this, there are 2 moments acting. One moment is this, other moment is this. You know that this hinge support can give reaction in terms of moment also. So it will be giving this reaction in terms of moment M. So moments are already balanced, so there is no point of this support reaction. So you would be having RA to be 0. So my dear, if you will be taking the section here, if you see to the left hand side or to the right hand side, there is no vertical force. So as there is no vertical force neither in the left hand side or in the right hand side of the section, so that is why the answer for this will be 0. So the answer for this is 0. Okay. So this is a very good question. I say generally students in the hurry, they are going for M by L. So that shows you that how clearly you observed it. Okay, and you have given the right answer. In GATE also they are going to give you shock like that. So my dear, I have taken today because I know this is June month going on. So in June month, according to your preparation level, I have taken the question. Like with the time, obviously we will increase the level, obviously. Okay. So because till now you have completed the SOM and some of you may have not practiced even PYQ. So according to that, they are very good questions. They are of exactly GATE level. In the upcoming sessions, like upcoming months, we will take slightly harder question than very hard question also. So day by day, we will increase the level. So for practice, here our sessions are going to be a very good source for you guys. Moving to question number 6, guys. Here we have the simply supported beam as shown in the figure below is subjected to these types of moment, and here you need to choose which bending moment diagram is correct. So I am making this loading there so that you can choose accordingly. A, B, C. The loading is like this. I am making it. M to M. M to M. L by 2, L by 2. Yes. So you can choose which of the diagram, which of the following bending moment diagram is going to be the correct one. You need to see the bending moment diagram. Yes, this is a very good question. Let us see how many of you are able to give the right answer. Question number 6 it is. Question number 6 it is. Yes, guys. First of all, you need to find out the support reaction. Graham Bell is saying B. B is wrong, Graham Bell. That's why I said every time don't tick it like that. First think about the question. Dear, first of all, you need to find out the support reaction. This and this, because they will also create moment. If you see this M is clockwise, this 3M is anti-clockwise. So that moment is 2M anti-clockwise. So in that case, this is also create anti-clockwise. So this reaction is minus 2M by L. And this reaction will be 2M by L. This reaction will be 2M by L. Is it clear? And you need to also take care of one more thing. They have taken downward direction as positive. They have taken downward direction as positive. So if you would be taking a section here, to the left hand side, you have a bending moment of M. First of all, only that bending moment diagram can be correct, which will be having 3 jumps at A, B and C. So here we have 3 jumps. Yes, it can be the right answer. Here we have 3 jumps. It can be the right answer. Here there is only 1 jump, no jump. There is no jump. So obviously this cannot be the answer. First of all, D is removed. Now here we have 1, 2 and 3 jumps. So A, B and C can be the answer. First of all, this is rectified. Then my dear, we need to see one more thing. You have here jump of M, and if you see the section, it is sagging. You know the sagging hogging concept? This is going to be sagging and this is going to be hogging. So if you see this, this is creating sagging. Sagging means positive, they are downward direction, they are taking it positive. So there will be a jump like this. And if you see this jump is of M. Okay, this jump is of M. Then my dear, after that, this is a 2M by L. So this 2M by L will also be creating sagging. So when this will be creating sagging, if you want to find out the bending moment equation, it is going to be plus M and plus 2M by L into X. This is the case. And my dear, if you want to use it, this is valid from A to C. So if you will be putting X is equals to L by 2, then L will get cancelled out, 2 will get cancelled out, and you will get the value to be 2M, where? At bending moment at C. So my dear, here this is the 2M value. So obviously this is going to be inclined line because here x ki power 1 is there. If you see here, it is constant. So obviously this is not correct, first of all. Okay. And second thing, my dear, if you see here, it is going like this. This is not correct because here we are getting 2M, although this value is M. So my dear, that is why this is minus M. So C is also wrong. From here we can say A is correct. After that, if you want to see, if you take the section here, to the right hand side you have moment of M, sagging. So there should be M jump of positive. It is there. After that, because of this minus 2 ml, you will be having once again declining like this. So from that, we are very much clear that answer will be A for this. You can also take the equation 2 bending moment at 2 is equals to the right hand side, this is plus M and this is creating minus 2M by L into X. Here also X ki power 1. Okay. So it is decreasing when you will put X is equals to L by 2. You will be getting bending moment at C to be 0. Sorry, it is our B point. What we are saying, C is B actually. This is B now. Fine. So this is how we are going to say A is going to be our correct answer. So Nirved, Graham Bell, Nitesh and Jaya, everybody got it that answer will be A here, not B. Any doubt to anyone, please tell. Everybody understood? That answer will be A here. Yes, guys. Wonderful, 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 guys. So moving to the next question. This is, okay, this question. This is a very good question and I feel we are reaching to the question number 7. The question number 7. This question we will see in the 4 p.m. class today. This is the 7th question for today. A beam ABCD with simple support at A, B and D and internal hinge at C. So because of internal hinge, you can divide the beam into two parts. Hinge, roller. This is point C. And the second part will be this. We have 20 kilonewton here. So you know that because of internal hinge, here will be RC upward, here will be RC downward. And here we have 20 kilonewton. So this will be support reaction at RA, RB, RD. You need to find out the support reaction at B. You need to find out the support reaction at B. Yes. Everyone, please try. I feel this is very easy. I all the time tell you that you need to break the beam from the internal hinge, and when you are breaking, obviously this 20 Newton will try to rotate the beam here. So to avoid this, hinge will apply a support reaction here. But at C, net force is 0, so RC will be coming here also. So that this RC and this RC nullify their effects. So from the symmetry, you can see here RC and RD to be 10 kilonewton. This is 10 kilonewton. So now, my dear, you know what to do. RA plus RB will be 30 kilonewton. Take summation moment about A to be 0. Then you know that RC is creating clockwise. So RC into 2 plus 2 plus 1, 5. RB creating anti-clockwise. 20 creating clockwise. This will directly give you RB value. Solve it and get the answer. Jaya is saying D. Okay. Dukhi Atma is saying 10. Dukhi Atma, please check. Okay. If you are talking about this, then it is correct. But RB value is not 10. Nitesh is saying 7.5. Yes. So Jaya and Dukhi Atma have given the right answer. 22.5 is correct. The answer will be 22.5. Because this RC cross 5 is 50 and this is 40. 90 by 4 is 22.5. Okay, it's correct. It's correct, Dukhyatma. D is the right answer. Okay, everybody got it? Nitesh, you got it? Nirved, you got it? Graham Bell, you got it? Please tell me. Very good, guys. So we are moving to the next question. This was question number 7. So guys, now we are moving to 8th question. This is from bending stresses. You can see we have covered almost all the topic. One question was from stress strain diagram, 2 from the Mohr circle, 1 from analytical method. Previous 2 questions were from the SFD BMD. This is from the bending. 1 question is from torsion we have. And then we have 1 question from deflection as well. So every topic is covered. Okay. So now we are going to see this question is for bending. So they have given that this is the neutral axis. And this is the distance of neutral axis from the bottom fiber. And this is from the top fiber. And you need to find out the maximum tensile stress. First of all, you can tell me this beam is subjected to sagging or hogging. Can you tell me the beam is subjected to sagging or hogging? The beam is subjected to sagging or hogging. Beam is subjected to sagging or hogging. Yes, everyone, sagging or hogging. It is sagging moment. And if yes, it is sagging moment. If yes, it is sagging moment, you tell me tension will be at the bottom fiber or top fiber. Tension will be at the bottom fiber or top fiber. This will bend like this. Tension will be at bottom fiber. Very good, Nitesh. Tension will be at bottom fiber. So you need to find out tensile stress. You know that sigma is equals to M into Y upon INA. That is the case, and I feel they have given the value of I about neutral axis. So you can write sigma maximum tensile is M into distance of bottom fiber divided by INA. So this is 5 kilonewton meter. You need to do the conversion of units. YB is 40.3 mm divided by 7.7 into 10 to the power 6 mm4. Solve this and get the answer. This is a very good question. Jaya, Nirved, Nitesh, Dukhi Atma. Wonderful guys. Try to solve this. This is question number 8. After that, 2 more questions, one from torsion, one from deflection. Solve it, guys. Solve it, solve it, solve it. Okay, Jaya is saying B, Nirved is saying B. Jaya is saying B, Nirved is saying B. Jaya is saying B, Nirved is saying B, and the answer is also B. So the answer will be 26.2. Okay, I am adding one part into this question. Can you also find out the tensile stress? Yes, very good. Can you also find out the tensile stress? Tensile stress will be at the top fiber. Sorry. Can you also find out the compressive stress? Compressive stress will be at top fiber. M into Y top divided by INA. Please give this value also. Please give this value also. Yes, Nirved. Please give this value also. Please give this value also. Very good, very good. This is not in the option, but try to, okay, this is also in the option. You can tell me which option will be there for compressive. In GATE also they are giving that kind of question. If you make any mistake, you will reach to the C. Okay, if you will be finding out this, you will reach to the C. So that's why if any mistake you are going to do, you can go for answer C also. So this is the sigma compressive maximum. But they have asked the tensile maximum. This is the sigma tensile maximum. Very good, very good, very good, Nirved, Nitish. Wonderful, guys. Moving to question number 9. This is from torsion. This is easy question. Intentionally, I have kept it as I said, because in the 4 p.m. session, once again I am telling you, today 4 p.m. we have app session. There also we will go for 10 question of SOM. And there we will have some very good level of question like this. Okay, there are some difficult question from deflection also have been considered. Okay. So be ready for that. 4 p.m. that session also will go for 40-45 minutes. I have shown you some questions which I will be discussing there. Wonderful level of questions. This is torsion question. You need to find out the maximum shear stress developed at the periphery of the shaft A. What about this question, guys? Okay. Dukhi Atma is saying 0. Dukhi Atma is saying 0. What about others? You need to find out the tau max, which is given as 16t by pi d cube. Anybody? Can you tell me what will be the twisting moment in A to C? Can you tell me what will be the twisting moment from A to C? Twisting moment from A to C. Twisting moment from A to C. Twisting moment from A to C. What about others, bhai? Nirved, right hand side there is no twisting moment, so T is 0. If T is 0, shear stress will be 0. But my dear, when you are going for the angle of twist, you are knowing that angle of twist theta A with respect to C will be 0, because that is going to be TL by GJ, because in section AC there is no torque, so that is 0 only. But if you will find out theta at A with respect to B, then it will be theta at A with respect to C plus theta at C with respect to B. So this is 0, but this is not 0. So because of that, this will be TL by GJ. So here, if you take this section for this is the value of torque. So my dear, this is T22 L upon GJ. So that is, I wanted to tell you that whenever you don't have any torque in a section, obviously shear stress will be 0, but angle of twist may not be 0, because that will be depending on for which point of reference you are finding out. So for this case, you can say theta at A is equals to theta at C, because in AC there is no torque. Okay, so if they would have asked angle of twist, their answer would not be 0. Mind it. So guys, now we are moving to the last question to conclude the session. Then I will show you, okay, this is the last question we are going to do, but I am showing you the questions, some of the questions which we are going to solve in the 4 p.m. session. This is the question we will be solving at 4 p.m. session. You can see it. By looking at this, goosebumps shall come. This at 4 p.m. we will do from column. Okay, likewise, this question from column. I also have shown you one more question before. This question we will solve at that time. So you can see wonderful question they are. Now this is the last question for this session. Question number 10. Nirved, then also it would not be 0. If torque would be at last, Nirved, like if torque is acting here, then also this tau will not be 0. Then tau will be 16 T by pi d cube. So at that point, if torque is 0, then stress will not come. This is the question where you need to find out deflection at end B. Okay. So this is the question which will be done by the equilibrium. I am telling you. You will divide this beam into 3 parts. Like this. First of all, you will say this is the load P. Then my dear, you know, for equilibrium of this DC part, you need a force P here to balance this force, and this force will also create a moment. So to maintain it in equilibrium, this moment will be there, P into L by 4. Now these both things are coming from BC onto CD. So obviously as a reaction, we will have one P here. This moment was clockwise, so it will give an anti-clockwise moment also, P into L by 4. Now for equilibrium of this is BC part. For equilibrium of BC, we would be having a force P here opposite and a moment this P into L by 4. And you know that at point B there is net load 0, like at point C net load 0. So that is why whatever we have applied here, we have applied opposite to that here. So that at C net force is 0. Similarly at B also net force is 0. So on this part you will be having a P downward. This moment is clockwise. So we will be having an anti-clockwise moment of P into L by 4. Now you can find out deflection at A for this loading condition. That will be your answer. So I feel you can write down the deflection at B formula. That will be P is going to create downward minus P, total length is L upon 3 EI. Then this is creating upward deflection plus this is principle of superposition we are using after going for equilibrium. ML square upon 2 EI. Here M is P into L by 4. Try to solve it. This is a very good question. Okay, Dukhi Atma have given the answer as B. What about others? You can try this. I have given you the net result. M is P into L by 4. So it will be minus PL cube upon 3 EI plus bending moment is P into L by 4 into L square 2 EI. So it is PL cube upon 8. Okay, PL cube upon 8. So you will be taking 24 LCM minus 8 plus this is 8 3 ja PL cube. Answer will be 5 PL cube upon 24 EI. B is going to be the right answer for this. Very good, Nitesh. Very good, Jitin. So guys, once again I am telling you, if you have missed this session, you can see the recording and you have one more option for 10 new question. Whatever we have discussed here, those 10 question will be different at 4 p.m. today on app. 10 question of strength of material. You can join me. Okay. So this is for today. Okay. And guys, one more session will be there on the YouTube. Tomorrow it will be in the video section available. That is related to the Sunday ka funda with how train changes railway track. How train changes the railway track. On that, this Sunday ka funda will be coming. You will get to know some technicals about how train is going to change the rails while going to some station. And my dear, one more thing, you will get the benefits of giving 2 papers of gate. So these 2 sessions you will see in the next 2 days. Don't miss this session. They will give you some wonderful things which you need. And if you already would be knowing about the benefits of giving 2 papers, then you will be preparing accordingly for the second paper as well. Because I have seen, like yesterday also I got a call from one of the students. He didn't qualify mechanical paper. But in the second paper, he got 150 rank. And from that, he got IIT Chennai, IIT Madras. Similarly, one student, mechanical, he got not very good score, 40. From AXI, he is getting some IIT. So this is the benefit. If you are miss the opportunity in mechanical paper, you cannot go to PSUs. But IIT, you can still get from the second paper. So second paper is going to be a second chance in the same year for you. So I will be taking that session. Be ready for that. You will get a lot. And you can share this session with your friends as well so that they can also get benefited. So goodbye guys for this session. We will meet again soon. Goodbye. Nirveds. Tomorrow. One video will be coming tomorrow. One will be day after tomorrow. Okay. Tomorrow they will be live. So you can watch it. Okay. So goodbye guys for this particular session. We will meet again soon.